Welcome, everyone. Kevin Carpenter back again. Another interview video. My first time with Greg. Greg Law, CTO of Undo and co-founder. Am I right?
You're well, no, CEO. I had a temporary promotion to CTO, but I'm back
Oh,
demoted to CEO now.
I don't know though, because I saw your first. For me, my first GDB talk I ever saw with you was 2015 at CPBCon. Of course, we're talking about CPP on C, but that talk, I wasn't even using GDB at the time, and I'm like, okay, if I ever have questions about GDB, I know exactly who I'm going to ask. So,
Yeah.
how long have you spent doing, GDB?
Oh gosh. I mean, I like probably first used it in early '90s, early mid '90s maybe. And but just as just like most people use it, right? Put a breakpoint, print some stuff, and run and continue, and that was kind of it. And it wasn't really until we got going in earnest with Undo, for which we use GDB as kind of our most used front end. So what
Mhm.
Undo sometimes gets mischaracterized as an extension or a front end to GDB or something, and it's very different than that. It's a uh, record and replay engine. It allows us to record, capture the process execution, and rewind that to any point in the past. And we use the most common interface onto that is GDB, or what we call UDB, which is kind of some changes we've added into GDB. And so it was through that journey and integrating our uh, our time travel recording engine with GDB that I learned a lot about GDB along the way, as you kind of tend to do. And then, through that realized, and then working with customers, with early customers, and you'd get a lot of, oh, well, I tried to do this with GDB in your product and it didn't work. And I'd be like, oh, I didn't know you could do that. I need to go find out like, what is that? And how do we make that work? So this would be in the early days, like just simply like, oh, I tried to call a function. And if you're trying to call a function in a time travel recording, if I've captured the execution of the process, I've rewound, say, to 2 minutes ago in history or an hour ago, and then you try and call a function, like what does that mean, right? And maybe maybe that function connects to a database that isn't there anymore. Like there's some stuff to work around. So we had to make all that work. We realized early on we needed to make that work. And then, and then people would ask about, I don't know, catch points and, all these other features. And so through that process, you realize, oh, wow, there's actually like lots here. I've still never like read through the manual from beginning to end because I'm still like demand paging this knowledge into my brain. And these days I go and do talks on it, and people ask me questions, and pretty much every time someone asks me a question about some obscure thing, and I go, oh, don't know. I guess I didn't know about that. Never heard of it. I need to go and find out. So they say the best way to learn something is to teach it.
That is true. And that's kind of funny because I'm like, and the best way to add new features to Undo, evidently, is when someone asks a question, it's like, oh, wait.
Yeah, yeah, exactly. Yeah, I
So,
figure it out as I go along, like everything in life.
yeah, that is I mean, life wouldn't be fun and exciting if we weren't kind of, you don't know what you don't know, and then you run
Yeah,
into it.
exactly.
So your talk fixed your hardest bugs with ease with time travel debugging. That's what you're doing at CPP on C. Um, so I have to ask, because obviously, Greg, I see you at a lot of conferences. All of them. You've been a great support for all the conferences, which everybody appreciates. But when I think about the time travel debugging, the way you just explained it, okay, so threading, production, where is that actually running? How is that affecting? Am I running in a debug mode when I'm running it against the time travel debugging? If I'm running multiple threads, is there kind of a limit to the amount of threads I'm going to track? Data storage. Can you give me just? I mean, I want everyone to come see your talk for the details, but can you give me a kind of synopsis on that?
Yeah, yeah, absolutely. So the time travel debuggers that are out there, of which Undo is just one. There are well three good ones, of which Undo is one, and they all work with production code just fine. They don't
Mhm.
require you to run a debug build or anything like that. They all run with as many threads as you want. Now, you will get into scalability issues when you run into, dozens, hundreds, in some cases, even thousands of
Okay.
threads. We have seen that. And so you'll start to get, slowdown will start to get impacted pretty badly at that kind of rate. But if you're running with 16 threads, 32 threads, something like that, generally not a problem. These technologies will handle that kind of scale well. Yeah, it's a common question. Well, do I need to be running with the debug build of my code? And yeah, absolutely not. So none of these time travel tools, they don't work by trying to do some kind of static analysis of the code because it just doesn't really work to do it that way because you don't know what's going to happen. I mean, in an extreme case, but this is like legit a thing, maybe you scribble onto the return address on your stack and return from the function into hyperspace and start executing that, right? That's a bug that happens
Mhm.
and we need to be able to cope with that. So we don't rely
Right.
on any kind of static analysis or any even any debug info, other than when you're in the time travel recording and you want to say, print my data structure, then
Right.
the debug info is used to kind of reference that. But that's just in the way that normal GDB would. So just because you can attach GDB to an optimized build program, you might get some challenges like value optimized out and all that kind of problem, which
Mhm.
everyone hates. But it works, right? And it's exactly the same with time travel.
That's really interesting because, when I think about it, when you're talking about the unlimited threads, for the most part, we process billions of dollars of transactions a month, and yeah, we're in that 12 to 16 thread range, which gives me comfort because we're not using your product yet, but we might not be
Mm,
far away.
yes, well,
So,
I'm glad to hear that on both fronts. Yeah.
and so you're going to give a demo, I'm sure, when you're giving your talk at CPP on C.
Oh yeah, yeah. Always demos. Yeah, yeah.
Excellent. So if you don't have your tickets for CPP on C yet, you want to come see Greg Law undo and the demo for time travel debugging so you can fix stuff easy because multi-threaded code is the last thing it's the last thing anyone on my team wants to debug without actual help.
It's horrible, right? Because I mean, threads. They'll. I always say there's two things that make bugs hard, two kind of dimensions to it. One is how long elapses between the bug itself and you noticing, which is why assertions are a good thing, right? They will narrow that window.
Oh yeah.
And why bad results is always the worst. Ran for hours, give me bad results. Oh my God, the bug could be anywhere. And then the other kind of dimension that makes bugs hard is how deterministic is the failure mode. Race conditions by definition are non-deterministic. They kind of score really badly on that dimension. And they tend almost always to be these kind of sort of silent killers. They had some corrupted state that you don't trip over till sometime later. So yeah, everyone hates debugging multi-threaded issues. They're just the worst. And it's one of the kind of it's really one of the killer features for time travel. I want to say in my talk, there will definitely be some demos. And I always I'm always happier. I always think I prefer doing talks which are more typing at the console rather than sort of showing slides. But this talk, I do get into quite a lot of not the theory, but the practicalities of how do you implement this. This is really what the talk is about,
Mhm.
not so much.
Oh
It's
wow.
definitely not a product pitch. Never, always very careful not to do talks on that front. And um, it's a little bit of like, this is what you get, but like 80% of it
Mhm.
is like, so how do you do that? How would you build these things? And what are the design trade-offs?
That's really cool. So that will be even more interesting to see. And if anybody wants to see you know, the pitch, they can always go to the table because
Oh
your
yeah,
team is always really good with helping out when
yeah,
questions need
absolutely.
answered.
We'll always be there. Yeah, doing demos and answering specific questions. But that's why candidly, that's why we love going to conferences, right? Because it's just a way. What we find with this stuff is it's still, we've been going for some time, and even the newest kid on the block in the time travel world is RR, and even that's been now around for quite a few years. We find still it's kind of not well known, and it's
Yeah.
still a bit of a secret in the best kept secret really in the industry. So we find like having those kind of full duplex conversations with people that we can do at the conference,
Mhm.
which what a conference is, conference is two things. One is to kind of that transmit where the talker, speaker is presenting an idea, and the other half, or maybe more than half of the conference, is all the conversations you get, in the hallway and all that kind of stuff.
Yes,
Where
absolutely.
you enjoy. Yeah,
Yes. Well, I look forward to seeing you at the hallway at cpponsea. I'll see you in Folkestone in a few weeks.
you'll be there. Cool.
Talk to you soon, Greg. Thanks again.
Bye bye.